All you have to do is go out and have kids, and it will happen. So if you ever are in doubt about whether evolution is operating in a population, go back to these basic conditions. You can always decide whether it's likely to be operating or not. We can turn natural selection off by violating any of these 4 points. If there's no variation in reproductive success, for example, if there is lifetime monogamy and a one-child policy, there will be 0 variation in reproductive success if everybody just has one child. Of course, some people will still have 0, okay? But that's about as close as you can get. If there's no variation in the trait, if the trait is like 5 fingers, there are very few people with 6 fingers. There are some, but very few. If there's a non-zero correlation between reproductive success and the trait, if there is a 0 correlation between reproductive success and the trait, we'll go into all the conditions for that. That results in neutral evolution. Okay? Then things just drift. We'll have a whole lecture on that. Or if the trait is not heritable, if there's no genetic component to it, then it won't evolve. So natural selection, I wonder why it's doing that. Sorry. Natural selection does not necessarily happen. It only happens under certain conditions. Essentially, in picture, this is what I've just told you about natural selection. If there's variation in the trait, represented on the x-axis, and there's variation in reproductive success based on the y-axis, and there is a correlation between the two, represented by the fact that I can just about draw a straight line between these points, natural selection will occur and it will push the trait to the right. If all of these conditions except the correlation occur, so you have variation in the trait, variation in reproductive success, but no correlation, then you get random drift. And these two situations result in radically different things. This situation produces adaptation. It produces all of the fantastic biology that you're familiar with. It's produced meiosis, it's produced your eye, it's produced your brain. It's extremely powerful. This situation on the right, the random drift situation, is what connects microevolution to phylogenetics, and it's what allows us to use variation in DNA sequences to infer history. And I'll get to that. That statement right now is opaque. Don't expect that one to be transparent at this point. But 2 or 3 lectures from now, I will go into that in detail, and you will see that we need to have a process of drift in order to generate a kind of large-scale regularity that gives us timing and relationship in macroevolution. So both are driven by variation in reproductive success. The difference is in whether there's a correlation between the variation in the gene or the trait and the variation in reproductive success. If we have strong selection, we can get pretty amazing things. I could illustrate adaptation a lot of different ways. I could do it, say, with the leaf-cutting ants that were the first farmers. They domesticated a fungus 50 million years ago and have been cultivating it ever since. That would be one way I could do it. I could do it with the exquisite morphology of the deep-sea glass sponges and how efficient they are at filtering stuff out of the water. I could do it with the design of a shark's body. Lots of stuff. I'll do it with bats, in part because when I was a Yale undergrad, I worked on bats in this building. We had a guy that did research on bats at that time. Now, a lot of bats are insectivores, and they will hunt moths at night in complete darkness, and they do it with sonar. The bat only weighs about, say, 50 to 100 grams, and it is making a sound that is as loud as a Metallica concert when you're standing right next to the lead guitar's speaker system, okay? Or it's as loud, if you like, as a Boeing 747 taking off from a runway. It's this tiny little creature. It's making an incredibly loud sound. It's 130 decibels. It does that because the intensity of sound, the amplitude of sound, decreases with the square of distance, and it needs to detect an echo coming back from the moth. The echo coming back from the moth, which, by the way, it can pick up at a distance of about 20 feet, is about 1,000,000 times less loud. And it's only coming in about 1 to 2 milliseconds later. So imagine, there you are. You've gone, whoo! Except a lot louder than that. And milliseconds later, you hear, and you haven't deafened yourself. That's exquisite. It has all kinds of physiology in its ear to hear the returning echo, and it can actually discern whether or not it's looking at a kind of a fuzzy moth or a smooth beetle. The moth has all kinds of adaptations to try to get away from the bat. It hears the bat, bat's cruising around, moth hears the bat. Moth goes into a desperate spiral, diving towards the ground. Okay, bat starts to swoop in. There is a mite that lives in the ear of moths. I think you begin to understand the problem that this mite has. If the moth gets caught, the mite will be eaten. The mite solution, it only lives in one ear. If you collect moths and you look for mites in their ears, you will find that they are always only on one side. So the moth always has a clear ear so it can hear the bat. There's stuff like this all through biology. There's another kind of a bat called Noctilio, hunts fish. Noctilio basically detects ripples in the water surface, and then it swoops down and it gaffs the fish with its hind legs. It can detect a wire 1/10 of a millimeter in diameter sticking 1/10 of a millimeter above the water surface. When I was taking care of bats, I had never seen a Noctilio. I thought, God, this must be the greatest bat in the world. About 4 years ago on the Amazon, my wife and I went out in a canoe at sunset on a lake just off the Amazon River. It was starting to get dark. All day long, the kingfishers had been fishing on that lake. And during the day, the lake had gotten covered with a lot of food that the fish wanted, but they were afraid of the kingfishers. As it got darker, the kingfishers couldn't hunt anymore, and the whole surface of the lake dimpled with the fish coming up to eat the food. So their timing was exquisite. They knew exactly how dark it had to get before they were safe. Fish came up and started to eat the food. At that point, it was just shortly after sunset, the bat falcons were still stationed around the lake. You could see up on the trees, falcons sitting up on the limbs and making flights off of the limbs. About 15 minutes after the fish started to eat, it got dark enough so that the bat falcons couldn't hunt anymore. And at that point, Noctilio came out, and the water was covered with hundreds of bats that were catching the fish. They were catching the fish within a meter of us. Now, there are a couple of things about that story that I think I'd like to underline. One is that that entire community is exquisitely adapted. Every element in it knows when everything is going on and what the risks are and what the costs and the benefits are. The other thing is that I had benefited from a liberal education, and when that bat came out and was flying around a meter away from my canoe in the Amazon, my life was so much richer because I had been waiting to see it for 40 years. I had heard about it in a course at Yale. I knew where it fit in. I knew what kinds of adaptations it had, and boy, was I happy to see it.